Aloha! Today, we're going to continue to use the closed interval method to find the exact maximum and minimum values of a function. In this example, part A, we're going to use a graphing device to estimate the absolute minimum and absolute maximum of this function, f of x equal to x minus 2 sine x, where x is greater than or equal to 0 and less than or equal to 2 pi. And then in part B, we're going to use the closed interval method to find the exact absolute minimum and also absolute maximum. Here's a graph for the function f of x equal to x minus 2 sine x. We're going to focus on the interval from 0 to 2 pi. By moving the cursor closer to this maximum point, we see that the absolute maximum is about 6.968 and the absolute minimum is about negative 0.685. Now in part B, we're going to use calculus to find the exact minimum and maximum values of this function on the interval from 0 to 2 pi. We're going to use the closed interval method. There are 3 steps in this closed interval method. The first step is to write down the domain of the function. In this case, this closed interval from 0 to 2 pi is the restricted domain for this function in this problem. So domain is the closed interval from 0 to 2 pi. The second step is to differentiate this function and find critical numbers on this closed interval. The derivative of x is 1. Derivative of sine x is cosine x. So f prime of x is equal to 1 minus 2 cosine x. We're going to find critical numbers by setting the first derivative equal to 0 and also find out when will the first derivative be undefined. Notice that the derivative here will never be undefined because cosine x is defined for all real numbers. So we want to investigate when will 1 minus 2 cosine x equal to 0. So when cosine x is equal to 1/2. Remember, we're trying to find critical numbers. Critical numbers has to be inside the domain over here. So we're going to focus on this domain from 0 to 2 pi. To solve for cosine x equal to 1/2, where x is in 0 to 2 pi, let's take a look at this unit circle. We know that at the first quadrant, cosine of pi over 3 is equal to 1/2. Cosine is positive when the angle is at the first quadrant and the fourth quadrant. Because cosine is adjacent over hypotenuse, the adjacent side here is positive at this 2 quadrant. So cosine is positive at this 2 quadrant. So one of the angle will be this angle, pi over 3. Another angle will be this angle that ended over here, which is going to be 2 pi minus pi over 3. That's equal to 5 pi over 3. So these two numbers are the critical numbers because they are in this domain of the function and they make the first derivative equal to 0. Step C is to make a table. It has 2 rows. The first row will be for those x values. The second row will be for f of x values. And we put the two ends of this closed interval at the two ends of this table. We put the two critical numbers in this table. Now we substitute all these x values into the x here in this function to find the corresponding f of x. We have f of 0 is equal to 0. We have f of pi over 3 is equal to pi over 3 minus 2 times sine of pi over 3. Sine of pi over 3 is root 3 over 2. So the result here is pi over 3 minus root 3. And we put it over here. We have f of 5 pi over 3 is 5 pi over 3 minus 2 sine of 5 pi over 3. Sine is negative at the fourth quadrant because the y here will be negative. So sine of 5 pi over 3 is going to be negative root 3 over 2. Negative times negative is positive, so simplify, we get 5 pi over 3 plus root 3, and we enter this into this table. We also have f of 2 pi is 2 pi minus 2 times sine of 2 pi. Sine of 2 pi is equal to 0, so the result here will be 2 pi. And we're going to enter this into the table. This is approximately equal to negative 0.684. This is about 6.968. This is about 6.28. So looking at all of this, the absolute maximum will be this number, 5 pi over 3, adding square root of 3. This number here is the smallest among all of this, so it is the absolute minimum. The absolute minimum is pi over 3 minus root 3. Notice that this is the exact value for this absolute minimum, and this is the exact value for this absolute maximum of the function. Those numbers down here, those are the approximations. The exact value will be this and this.